As a computer programmer, whenever we want to process a signal to change its perceived volume, we're going to use the multiplication operator to apply a linear gain change. This is something that we've already looked at. However, audio engineers typically think about changing a signal's volume relative to a decibel scale. In fact, it's very common in audio software to have a fader, a knob, or some kind of interface object that allows the user to provide a number on the decibel scale to change a signal's amplitude. So the way that this works is, as a computer programmer, we must be able to interpret this number on the decibel scale, convert it into a number on the linear scale, and then apply it using a linear gain change to our signal. Let's go ahead and look at using MATLAB to interpret the number on the decibel scale to change our signal's volume. Here's a demonstration of the process to change the amplitude of a signal based on the decibel scale. The important thing to understand is the relationship between the decibel scale and the linear scale. I'll start out with an example down here in the command window to show you this relationship. As an example, let's say we wanted to change the amplitude of our signal by -6 decibels. So we'll create a variable here to store the value on the decibel scale. What we need to do is calculate what the amplitude should be on the linear scale. So the expression we can use is 10 raised to the power of the decibel value divided by 20. Audio engineers should know that -6 decibels is just about the same as creating a signal that has half the amplitude, close to 0.5. We could also try out +6 as our decibel gain change. Put that into the expression, and we get something just about 2 or twice the amplitude. Now we can use this expression as part of our code to relate our decibel scale to a linear amplitude that we can use to scale our signal. Come up here to our code. This is what we created previously for our linear gain change script. I'm going to reuse it because it will be very similar. Still have a sine wave test signal that we're going to process, and we can then eventually look at it down here with this plot. We're going to add some new things in here. I'm going to say, put in a decibel dB gain value. So here, use the variable dB of -6. Should be about half the amplitude. This is where we can put in the expression of 10 raised to the power of dB divided by 20. When I run this script, we'll plot it and look at what the process signal looks like. So our blue signal is the original input and our red signal is the processed one. Has just about half the amplitude of the blue one. We could change this now to a value of 6 and look at the result. Our blue signal has now been changed in amplitude, so it has twice the amplitude, or 6 decibels more. So this is the expression that we can use to put in any value on the decibel scale, have it be converted to the linear scale, and then applied to our signal.